Okay, you can see in your notes that we are talking about the 30, 60, 90 triangle. And where that comes from is if you take a equilateral triangle, and in this case I'm just showing a drawing of a equilateral triangle that has sides, all of the sides are 4. And any equilateral triangle, all the angles are 60 degrees because there is a total of 180 degrees in any triangle. So this triangle has all 60-degree angles. The special thing about an equilateral triangle is that when you drop the altitude, which means you drop the perpendicular line from the vertex at the top, it will split the triangle right in half. And therefore, it splits that angle at the top in half, so it's 30 and 30. And then it also splits the base in half, so each side is 2. So the triangle that we're going to be looking at especially is the 30, 60, 90 triangle. There are many applications that involve the angles 30 and 60, and so it's a good thing for us to be able to know the trig functions for those angles. And one way to know that is to know the ratios of a 30, 60, 90 triangle. Because of the way we formed that triangle, we always know that when we have a 30, 60, 90 triangle, the short leg, which is the leg that's right across from the 30-degree angle, because remember, a right triangle has 2 legs. Those are the sides that connect the right angle, and one hypotenuse, which is across from the right angle. So the 2 legs in a 30, 60, 90 triangle, the short leg is across from the 30-degree angle, and the long leg is across from the 60-degree angle. So because of the way we made this triangle, and this is true for every single 30, 60, 90 triangle in the world, the short leg will always be half the hypotenuse. So if 2 triangles have the same angles, you're going to see this word in your book a lot, the word similar. And if you haven't taken geometry, then I will tell you what similar means. Similar means 2 triangles are similar if they have the exact same angles. And if they do have the exact same angles, they will be proportional. And the 30, 60, 90 triangle, you can see 3 30, 60, 90 triangles here. They all look exactly alike. Some are bigger, some are smaller, but they have the exact same shape. And the short leg is always half of the hypotenuse. And that would be true for any 30, 60, 90 triangle. So bottom line, you have to memorize the 30, 60, 90 triangle. You have to memorize these ratios. It's not too hard to remember because we split that equilateral triangle in half, that the length of the short leg is always going to be half the hypotenuse. So we haven't talked about the long leg of the triangle yet. So let's look at that. Let's call it x. We can find that by using the Pythagorean theorem now. So we know that x squared plus 1 squared is equal to 2 squared. So x squared plus 1 equals 4. Subtract 1 on both sides, and x squared equals 3. Take the square root on both sides, and you find that x is equal to the square root of 3. So now we know the relationship between the short leg and the long leg, and the long leg and the hypotenuse. So these are the ratios that you will need to know and memorize for any 30, 60, 90 triangle. That is that the ratio of the short leg to the hypotenuse, as we said before, is 1 to 2, or 1/2. So the ratio of the short leg to the long leg is going to be 1 over the square root of 3. And the ratio of the long leg to the hypotenuse is going to be the square root of 3 over 2. So what we're going to do is use these ratios to solve 30, 60, 90 triangles when we don't know some of the sides. So we're going to look at this example, 66.3, use proportions to find x and y. Your book will probably say use similar triangles to find x and y. Sometimes it will, sometimes it won't. But I'm going to show you the way that we're going to do this. So here you have a 30, 60, 90 triangle. The 30-degree angle is not marked, but you know it's 30 degrees because this is 90, this is 60, that adds up to 150, and every triangle has a total of 180 degrees in it. So this is a 30, 60, 90 triangle. You can see that Y is the short leg because it's across from the 30-degree angle, and X is the long leg because it's across from the 60-degree angle. So we have the hypotenuse, we know that. So if we want to solve for X, we would say long leg over the hypotenuse is going to be square root of 3 over 2. And we know that the hypotenuse is 5, so the long leg, which is X, is on top. The hypotenuse, which is 5, is on the bottom. That is supposed to equal the square root of 3 over 2. So if we cross multiply, 5 times the square root of 3 is equal to 2x. And so x, if you divide both sides by 2, is going to be 5 times the square root of 3 over 2. So that is x. That's the long leg. All right. Now y. We know that the ratio between the short leg and the hypotenuse is always 1 over 2. What that means is the short leg is always half the length of the hypotenuse. So without even setting up a ratio, we know if the hypotenuse is 5, then the short leg is 5 halves. It's going to be half the hypotenuse. So those are the values for those legs, the lengths of those legs. Okay, here's another one. On this one, again, I didn't tell you it was 30, 60, 90. I should have done that. So this is the 30-degree angle. This is the 60-degree angle. This only works with a 30, 60, 90 triangle. So sorry I didn't mention that. Very important piece of information. All right, so the short leg is A. And the long leg is 7. That's the side across from the 60-degree angle. So that's 7. And then the hypotenuse is B. We know that we can set up any ratio we want to. We could set up the short leg over the long leg. And so we know that right now that's A over 7. And we know that in every 30, 60, 90 triangle, the relationship between the short leg and the long leg is 1 over the square root of 3. So cross multiply, A times the square root of 3 equals 7. Divide both sides by the square root of 3. A equals 7 over the square root of 3. Now, normally I would not leave an answer with a square root in the denominator, so I'm not going to do that. I'm going to multiply the top and the bottom of this fraction by the square root of 3, and so I will have 7 square root of 3 over 3. That would be my final answer because I don't want to leave a radical in the denominator, so that's what A is. Since A is the short leg, I know the hypotenuse is twice the short leg. All I have to do is double this to get B, because A over B is 1 to 2. That's the relationship between the short leg, the leg across from the 30-degree angle, and the hypotenuse in a 30, 60, 90 triangle. A over B is 1/2, and that means that B is going to be double A. 2A equals B. And since I know that A is 7 square root of 3 over 3, that is 14 square root of 3 over 3. So for the 30, 60, 90 triangle, that is what you need to know. You need to know those ratios. And one of the easiest things to remember is that the short leg over the hypotenuse is 1/2. That means the short leg is always half the hypotenuse. The hypotenuse is always double the short leg. And then the long leg is just the short leg times square root of 3. So just get those ratios into your brain, and we will keep solving those kinds of triangles. And we will also use that information in the future to find the sine and cosine and tangent of 30 and 60 without using a calculator. Okay, Lesson 67 is about rationalizing denominators, which I just mentioned. We're remembering two things. One is that you should never leave a square root in the denominator of a fraction. And second of all, if you have a binomial and you change the middle sign of the binomial, remember a binomial is just a polynomial that has two terms, something plus something or something minus something. That's going to be a binomial. Remember that when you change the middle sign of a binomial, the new thing you have is called the conjugate of what you started with. So x plus y is the conjugate of x minus y. And remember that when you multiply conjugates, you get a difference of squares. It will be the first thing squared minus the second thing squared. So the product of two conjugates is a difference of squares. This is very important. When we multiply conjugates, we get a difference of squares. So, recap. A conjugate of a binomial is just the exact same binomial, but the middle sign changes. So the conjugate of 3x minus 4y is 3x plus 4y. It's not the opposite. I didn't multiply everything by -1. It's not the opposite. It's the conjugate. I'm just changing one of the signs, the sign in the middle. And again, if you multiply conjugates, you are going to get a difference of squares. It's going to be the first thing squared minus the second thing squared. Difference of squares, very important, something you'll see on a lot of standardized tests. It's a good thing to remember that the product of two conjugates is a difference of squares. If I multiply this out, I'm going to have 9x squared minus 16y squared. So, conjugates. Why do I need to know that for right now? The reason I want to talk about that is because sometimes you might have a radical, two radicals in the denominator, or just some kind of binomial in the denominator. And if you were to multiply this denominator by square root of 3, it wouldn't help. So if you multiplied this fraction by square root of 3 over square root of 3 to try to rationalize it, you'd end up with 3 square root of 3 over 2 times 3 plus the square root of 6. So you've still got a square root in that denominator even when you do that. So I'm going to multiply the top and the bottom of this fraction by the conjugate of the denominator. So 2 square root of 3 minus the square root of 2 over 2 square root of 3 minus the square root of 2. Because when you multiply two conjugates, you get a difference of squares. And a difference of squares is not going to have these square roots in it because they will be squared. So the numerator, we have to distribute the 3. So we'll have 6 square root of 3 minus 3 square root of 2. And then in the denominator, we're going to have the first thing squared minus the second thing squared. And so that is 6 times the square root of 3 minus 3 times the square root of 2 on top. And on the bottom, 2 square root of 3 times 2 is just 4 times 3, which is 12, minus the square root of 2 squared is 2. So you're going to end up with 6 square root of 3 minus 3 square root of 2 over 10. So it's still not a pretty fraction, but the denominator does not have any radicals. And that's the main thing we're talking about here. We're trying to rationalize that denominator. Okay, lesson 68 is basically just about how to use your calculator to do scientific notation. So it's pretty simple. Suppose you want to enter 3.5 times 10 to the 23rd power on your calculator. If you don't know how to do this, all you have to do is hit 3.5, and then instead of hitting multiply, you hit EE. And that is your button for scientific notation. It's telling the calculator to put 23 as the exponent on 10. So you don't ever push 10. All you do is you hit the first number, and then you hit the EE button, and then you hit the exponent. And that will tell your calculator you're talking about 3.5 times 10 to the 23rd. If you wanted to do negative 3.5 times 10 to the 23rd, you would need one more button, and that is the plus minus button. This button will change the sign of whatever you just punched in. So if you want negative 3.5, you can type in 3.5, and then when you hit that little button right here, it will change the sign on 3.5 and make it negative 3.5. And then you just continue the way you did the first one. You hit the EE button, and then you hit 23 to tell your calculator you want negative 3.5 times 10 to the 23rd. So again, anytime you want to change a number from positive to negative or negative to positive, you can just hit this little black key right here after you hit that number, and it will change the sign. So here's another thing you need to know, and that is how do you take different roots of numbers. You may already know this. You may already know what we just talked about. But suppose you want to enter the cube root of 8 into your calculator. To do that, you would hit 8. Then you would hit your second function, and it would be right here, your y to the x key. Except if you look at above the y to the x, you can see that it's the x root of y. So if you want to take the cube root of 8, you first of all hit the 8, hit the thing that's inside the radical. Then hit second function y to the x. Then hit the root, hit the little number that goes here, and then hit equals. And that will tell you that that is 2. All right, so if you wanted to evaluate something really crazy like the 3.28th root of 50.42, you could just punch that into your calculator. That would be the only way you would get an approximation for that. So you would hit 50.42, so you're hitting the number that's in the radical first. Then you hit the second function, y to the x. Then you hit this little root sign, 3.28 equals, and if you punch that in correctly, you should get about 3.30. And then for the last example, this is just raising a number to a power, and you just use your regular y to the x key for this. All you do is you hit the base, which is 9.26, then you hit y to the x, and then since this is a negative number, you don't hit the minus sign first. You punch in the number first, 4.58, and then after you've punched that number in, you hit the sign that changes the sign on the number. So 9.26, that's the base, hit y to the x, then hit the exponent without the negative sign. After you hit 4.58, then hit this little button that changes the sign on it. That'll make it negative, and then you will get your answer when you hit equals. So 9.26, y to the x, 4.58, change the sign, negative, equals, and you are going to get about 0.00037. So that's all there is to 66B through 68. And if you are struggling with anything on the homework, please don't hesitate to give me an email or a text, and I can help you with that.